Hi, my name is Pritham Reddy from PS2. In Milestone 2, we discussed about like how the LLMs are working together, how the Llama model and the Gemini model are integrated together, and we use an technique called a bagging technique in the Milestone 2, where the weak learners come together to give a more accurate response. And we also worked on how the RAG implementations are done and how the LLMs and the RAG implementation components are connected together, like to get the response from the LLM model, or how the vector database will give some context to the LLM model, and the LLM model will understood the context given by the vector database, and it will give some response called y. And here, like in LLM integration, we use a technique, bagging technique, and we integrated the two LLM models, like a Gemini model from the Google and Llama model from the Meta. We integrated the two LLM models like serially with the uh, technique called bagging technique, where the we discussed in the milestone 2, where the will give some prompt to the Gemini model, and Gemini model will give some response, and the response will be sent to the LLM Llama 2 model, and Llama 2 will give some response called Y. So this response called Y is more accurate. Like we also discussed in milestone 2. So in milestone 3, we'll discuss about what are the modifications are done since milestone 2, and we will discuss about like what are the versions we use, like in MongoDB, which version we use, and Python which version, and React which version, and some use cases and some use cases of our project, like C2C or B2B, like business to customer or customer to customer. Like in further, is there are any potential upgrades are going to be done in our project, and how the front end, and mainly the main goal of our milestone 3 is how the front end and the back end are connected together, and we'll show a small demo of our project. Yeah, let's discuss let's go to next slide. Yeah, like what are modifications been made since milestone 2? Yeah, we have developed on in milestone since milestone 2, we developed like a huge we developed our project using React. Like we completely did our project using React and a Flask as our backend, and we are also added in text to speech functionality, and there is an language translation also. Like a user can select 10 different languages to for a response given. And we also explored on in milestone 2 modification sector. I said like we are going to use any offline embedding model, but later yeah, we also used an offline embedding model from the my Hugging Face. But we later realized like embeddings are done very slow, and it is very time taking. So later we realized to use a Google generative AI embedding model from Google only, like API type, like online model. So yeah, these are some major modifications are done, like our React and text-to-speech functionality or translation functionality, and yeah, these are some major modifications are done. Yeah, to come, like what the versions we used in our project, like MongoDB we used 8.0 version, and Python we used like a Python as a backend. We used a Flask. We used a 3.10 version uh, with PDF processing done, and the query will be a query from the front end will be sent to the backend, and backend will give some response to the front end. Will display that response, like using Python. We used Flask as our backend, and we use React as our front end, like 18 version. 18.2 version is the latest, but we use 18.00 version. Yeah. Uh, so let's discuss what are the main use cases of our project. To before discussing use cases, let I will give just brief explanation of our project, like overview, like example, like yeah, if I am a user of or my if I am a user of my website, initially I will select a file. I will choose a file. Example, if in a Mahabharat summary file, I will select a file, and I will upload and process it, and I will get an done button, like the PDF is uploaded and processed successfully, and I will enter a prompt, I will enter a query in our box. I can also select a language, like there are some 10 different languages, and I can select a 10 language, uh, like English, Telugu, Hindi, anything, like Turkish, like blah blah. So I can select in 10 different languages, and I will press on I will enter the I will enter a button. So it will take a couple of minutes to get a response. I will get a response. And is there and We also have an option of a text to speech option, and after getting response, we can also change the languages, like in 10 different languages we can view the response. So this is an overall view of an project, like just overview of an project, just like how it's going to be look like from the user view. Like let's discuss the what the main use cases in our project, educational assistant, we can say. I personally used my website for an test act assessment preparation, where the like for example, if there is any exam tomorrow, like OS assessment exam tomorrow, test act exam. So I will upload an I will upload an if there is an free space management example, a top we will take in free space management as a topic from the OS. I will upload a PDF called free space management, and I'll upload and process it, and I will ask question like what can you say the what are the disadvantages in bit mapping of free space management, and it will I can select in languages, in which language I want the response, like English, Telugu, Hindi, and I will click on an enter button. It will generate the response from where the in which language I have selected. So in educational assistant we can use, and research assistant, where the researchers can also upload their papers and they can ask some queries according to it. And with customer support, like where product will give some information PDF on a product, so customer can clear his doubt using our website, where the product PDF can be uploaded in our website, and they can use our website to clear their queries. Like they can ask any question based on a product, and our LLMs will generate the response accurately. Yeah, these are some major use cases. Let's discuss about front end. Like a front end mainly done using React.js, JavaScript, CSS. Obviously, like we connected our front end with backend to get the response. Like initially, we will upload in PDF and we will process it, and we'll ask any user question to it, and user question will generate some response. So like this is from user view, but what internally happening is we don't know. Like this is our front end. Like what I said now. Like this is like user view. Like what the user is viewing is called like front end. Basically, so what I am the user is seeing, the website is called front end. Like what is displaying, what I am asking, like what I'm selecting is called front end. But basically what is happening inside is called it's called back end. We use our LLM is giving some response back to the front end. The LLMs are running in the back end, and the user question and the response are storing in the back end in the MongoDB. I will discuss later about back end. Let's discuss about front end. I will run our project like in our front end. In our front end, I will show the like basic code of our front end. So yeah, this is our basic page, like we can say. Uh, I will choose a file and I will upload it, and I will ask any user question here. And I will select in 10 different languages. I will select by default it is English. I will select in Telugu and I will ask a question. It will generate some response based on the user query. Let's see what will be how to run it. So I am in chat with author front end page. I will run npm. I will run npm start npm start. So our front end will be start. Our front end will be running in the server. So this is our front end. Though, so there are some stored queries where previously stored queries in our backend, but we didn't run any backend at now. So there are no stored queries in our here. So we can see, like we can choose the file and we can upload, and we can ask any question here, and we can select any language, 10 different languages, and we can ask any we can ask the question. It will generate the response here, like a response called some by from the bagging technique, you can say. Yeah, yeah, this is our basic front end. So chat with author front end, SRC. Have divided our front end into file uploaded one component, and query form component, query list component, and response component. Like in file uploaded, I will send an post request to the backend server, like where the flask is running here, 5000 upload PDF. I will send to there. So my PDF will be uploaded, and if there are any errors, I will get error uploading, or else I will get any done error done, yeah, your PDF is uploaded successfully done, I will get. If there are any errors, I will get error uploading in PDFs. So this is my file upload .js, that component. In query form component, I can ask a query, and I can translate. I can choose my language to the response. And Yeah, I have also a speech button, like a text to speech button, like where the speech will be where the text will be converted into speech. So there are some post requests here also. Like let's see, like this is a process query which is running in the backend. I will discuss later, like what is running backend mainly. We can see the axios dot post, like HTTP 1000 127.0.0.10 500 process query. So my user query will be sent to this URL where the backend is running. I will get a response. I will get a response called Y, and which will be shown in my front end page. So if there is any error getting response, I will get, I'm sorry, I cannot answer this question based on the provided context. And we are also having a backend for the translator where this is running in the port 1 to 127, like localhost 8000, we can say. The input will be generated response and the language, like which language the text should be converted. and and obviously I need to save my query, and my need to save my user query and the response. So I'm using in backend localhost 4000 a save query name. I will save user query, user question as a user question, and the response like translated what the translated text, like translated response I will store. So the user question and the translated text are stored in the MongoDB in the backend. I will discuss later like how I'm storing and how I'm getting it. Yeah. uh Hmm. So I will select some 10 different languages here, and it will be processing it. Like I have to wait for a couple of minutes. I will get some response, translated response. And coming to query list. Query list is nothing but like I will get some, I said na, like there are some saved queries in localhost 4000 where the queries are saved in the backend MongoDB server. I will get all the uh, I will get all like key value pair from the MongoDB server. Like I will use access.get and localhost name where the queries are stored with the name get queries. Yeah, I will get, and if there are any error in this, like we'll get error fetching queries. Uh, I have like stored queries. Okay. Yeah. And I will when I click on it question, it will show the response. Like I will discuss like it later, like how the backend will run, and how the user question will be stored query will be selected, and how response will be shown. And these are some CSS for it. We mainly the main resource for our CSS is we use a ChatGPT and some like Google documents, like for we can say like a CSS documentations. Uh, yeah, it's done like more. This is mainly our front end looks like. We divided into like four components: well, file upload.js, query form.js, and query list.js. In file upload, we are just uploading the file. If we are uploading the file and we are sending the request to the backend server, where the file uploading will be done completely in the backend, and we'll get will get done as an done if the file uploaded successfully. And it will be file uploading error when it will fail. File uploading will be failed. We will get failed file uploading is failed. And there is a query form.js, like where we'll ask some query and we'll select in different languages, and we also have an speech button where the text completely will be converted into the speech. Yeah, this is amazing. Like this page is amazing. Like query form.js will be the more important front end for our project. Like we use like different backends we are using here, like query process.js, where the question will be sent to the backend, and backend will generate a backend LLM will give some response, generated response, and generated response will be shown in our page. Like translated response will be shown in our page, and generated response is sent to the translate Google API server, like we are running in backend. The generated response will be converted into the language which the user is selected. And the user and the we can uh, and the user query and the response, like the translated response will be saved in the MongoDB server. I will show like how the query will be saved, like in the MongoDB. It's okay, like yeah, it's like complete. This is our main front end pages. And this is app.js, where I will use like file upload at query form, and response dot response and query list here, like chat with author image, like file container. I stored like file uploaded. user form, user list, in order. Yeah, this is my complete front end. Let's go next. This is complete front end. Yeah, to like we will discuss now. We'll discuss what's what backend we use. We used Flask server backend. We use Flask for backend where LLMs provide response to the front end. LLMs will I have divided the Flask backend into two parts. For the user will upload a PDF. It will be a post method, and the query process will be a post method. So there are some two parts uploading PDF, and user will ask any query to the LLM, and LLM will generate some response to the LLM will give some response to our my front end. So I will explain how the backend and the front end are connected. How they are connected. I said, in front end discussion, I basically showed just the URLs post request to the backend. But now I will discuss how my backends are running in my VS Code, and I will show what commands we need to run my backend code. So, file directory. I will show the file directories. There is so basically I divided my backend into three parts: Flask backend, MongoDB backend, and translation service. So I have already said that we are using an app.py for app.py as a Flask backend, where I will upload the PDF and the PDF processing will be done in app.py. And there is also there is an also when user will ask any query to the backend, the process will the user question will be processed in the backend, and it will generate some response called y to the front end. It will give back the response from the LLM to the front end. So this is Flash backend, chat with author backend. We can see here there is a code in app.py, I have explained in milestone 2, complete code of an app.py. You can watch it there. Yeah, and MongoDB server, where the user question will be user query, and the response will be stored in the MongoDB and will be displayed on the screen. I will show how to run a MongoDB. We can see MongoDB backend and translation service. We can select where the user will select in different languages. Where we can choose our language for the response. Where you're using Google API for the translation, the response will be sent to the backend and written in the user selected language. Yeah, obviously, user will select a language, will be written. The response will be written in the user selected language. We can see a translator. So server.js. I will show everything. For initially we can see here MongoDB. We will go into this directory, open integrated terminal, and I will run. I will see what file is there, server.js. I will run node server.js. So so MongoDB is connected, and my local host is running in 4000 port. And I also discussed in query form, where I'm storing the response. Wait a second. See here, in HTTP localhost 4000, this query will be saved. Where in MongoDB, I will show the MongoDB later. Yeah, where am I? Yeah, server.js, where the MongoDB is running. So the MongoDB server is on. MongoDB server is on. So MongoDB is connected directory name queries, and MongoDB is connected. Yeah, and there are two post methods: save query and get queries. In save query, we will save the query. We will save the user question and the response in the MongoDB. In get query, we will get the user question and the uh we'll get the user question and the response from the backend, in localhost 4000, we can say. I will show my MongoDB, where the uh where the queries are stored. We can see this queries. See, this is my MongoDB version. The user question and the response are stored. Explain me about copy command, and is the user question, and this introduction to copy command is a fundamental in computing. That is a response from the LLM model. So this is my MongoDB version. Yeah, I will show in more clearly. So I will come to my front end, and I will refresh it. We can see the queries which are stored in the backend. So these are some queries which are already entered before doing milestone 3. So I'll click on it, explain me about copy command. So here we can see the response which is given by the which is given by the backend. And I will click on it, and this is in Telugu language where the user is selected the response to be in Telugu. And this is about neural networks and Linux commands. So these are some different user questions asked by the user, and which are saved in the MongoDB server, and which will be displayed on the screen using uh, get method, like save get queries from the localhost 4000 will get it. Yeah, this is MongoDB server. And I will now run. I will go to translator, open integrated terminal. I'll go to translator, and the file name is also here. Also, its name is server node server.js. I will run. So the port is running in 8000. So we can see in query form, like I will go to query form, and I can see here like HTTP 2000, like 127.0.0.1 8000, like where the port is running. I will send and generated response to the I will generate a generated response to the 8000 port, the when where the whole where the where the 8000 port will translate my generated response to the user selected language. It's completely done by the translated server. So we can see here, like we are getting an API from the Google API dot translate a single, where it will convert my language to the user selected language. Like I will select if there is a translated text, like this is called translated, like empty text, and the response there is a response now. So the all the response like I'm sending in response, like response text to the this like a translated server, so translated API, where the translated API completely transforming the data, like response into the user selected language. So this is, if there is any error, it will show the error translating text, translation error. Server is running on the port 8000. So this is my three backends, and I will show the main backend where the LLMs and the PDF processing are done in the chat without the backend. I will open my integrated terminate, and I will run Python app.py. This is my Flask backend. Like I will show like completely, like I guess like I completely explained about like every each and every line of a code in milestone 3. I will just explain a Flask part of it, like how the root, like app.root. Here we can see like app.root and upload and PDF is a method called post method, like where the we can see like file upload method. In the upload file uploaded here will be translated here, translated into the backend where upload file, and PDF will be converted into chunks. And we know that like how the PDF text is converted into the chunks, and chunks are stored in the vector DB, and vector DB will generate some when the user question will be sent to the vector DB, and both the vector DB now contain both the user question and the chunks, emitted chunks. Then it will give some relevant information to the LLM models, and LLM model will generate some response called Y. So this is like the PDF processing will be done like completely. And I have also have an post method called process query, where an user will ask and query, like I'm taking an input as a user question, where user question will be sent to the where the user question will be sent to the vector DB, and vector DB has some relevant information of that question, and the vector DB will generate some context, like prompt plus context, and context will be sent to the LLM models. Like we are using a bagging technique there. Like I will show in further slides like how I'm using it. We are using some bagging technique that I will show it later. So our LLM models will generate some response, and then that response will be generated to that will the response will be refined response will be sent to my query form. Like I will display it here. Like we can see translated response. Yeah, I'm displaying it here. I will show like basic demo. So this is my Flask backend where it is running on port 5000, and in query form I can see like I'm processing my PDF on port 5000, process query name, post method. And and we can see in file upload we can see upload file is done on port 5000. We will process our PDF using, I will send it to backend will completely do, like I have completely discussed this code in milestone 2, like how the PDF processing is done, and how the LLM is generating the response, and And here here also I have discussed about like how the uh, how the how the response refined response is then again to the query form, and query form will generate some response here, will display it as a translated response. Okay. Yeah, now the all ports are running. The backend, three of my three backends are running, and our front end is also running React. So I will upload any PDF. Like I will choose any PDF. We can say like free space management. I will upload an PDF. We can see here uploading. Yeah, the PDF is uploaded. I will ask any question like based on the PDF. I will ask what are the disadvantages in bitmap I will ask linked list disadvantages in the linked list free space management. I will select in Hindi, and I will select in Hindi and I will ask question. So I have to wait for a couple of minutes to get the response. Like we are using offline models. We are using open source model, Llama 2 model. It will take it's completely running in my CPU, so it will take a couple of minutes of time to generate the response. So we will wait for a couple of minutes. Further we will discuss what's happening. Yeah, now we can I can discuss about the Llama 2 and Gemini working and workflow for LLMs. Like I will the prompt is generated from the vector DB, so the prompt will be given to the Gemini LLM. So if there is any response from the Gemini LLM, the response from the Gemini LLM called X will be sent to the LLM called Llama 2 model. So then the Llama 2 model will understand the response from the Gemini, and the Gemini will Llama 2 will be generate some response from the response will be from the Llama 2 finally. But if there is no response from the Gemini model, we will check either the question is related to the PDF or not. Like how we are checking the PDF, the user question is related to the PDF or not, using by checking using question similarity, user query is related to the PDF or not. I will send the Llama 2 model for the response. If the user question is related to the PDF, I will send the user query directly to the Llama 2 model, and Llama 2 model will generate some response. This is called my bagging technique, where the weak learners come together to give the strong response. We can say or accurate response. So these are some LLM Llama 2 and the Gemini models of working workflow. And this is in milestone 2 we also discuss about RAG and LLMs implement working together, and how they are working each other. The PDF will be divided into chunks. Like initially they are tokenized first, into, and we have some indexes for it. It's completely based on its vocabulary, and the tokenization, after tokenization it's complete, it's break into some chunks, and the chunks will be embedded into the vector database. Like we are using 5 index of Facebook AI similarity search, and which has both search mechanism and similarity mechanism. And we also send a user query, and it will be embedded into the vector database. And we now the vector database have the user query and the chunks with the information related to the query. So vector database will generate some relevant information, or we can say case similar documents from the vector database. So now the case similar documents will be sent as an prompt to the LLMs, where we can see here the vector DB is generated some prompt we are sending to the Gemini model, and this workflow we have discussed. So this is my workflow of an RAG and the LLM model, and how our LLM Llama 2 model and Gemini model working together. Hmm, what are the potential upgrades you are doing? In future we are planning to add some user authentication, and we also want to deploy a website in our any cloud service like Amazon Web Service. In further future we will do for adding user authentication. Like there will be security for the users who are using our website. There will be now our website is mostly on customer to customer. Like any customer can use our website, but in future it will be customer, business to customer, we can say like we are providing some business, and the customers will use the website provided by the business, like means like by our team. uh, and we can say the back end and front end workflow. There is a front end where the React, where the front end in React, and which is connected with app.py, where the LLM and PDF is uploaded. And there is also another backend server where the MongoDB, where the user question and user query and the response is stored. And there is a translation server where that user can select the language for to get a response in different languages to different. Let's see, like if there is any response. Yeah, we can see. What are the disadvantages in the linked list in the free space management? We can see some response from the our LLM model. We can select in different languages, like this is in Telugu language we have selected. I can select it in English language also, and I can select it in Spanish language also. So these are some. So this is our complete like workflow of our project, and we also showed a demo of our website, like how the user can use our website like completely, how he can choose our file, how he can upload the file, and how we can ask, and how we can like select the different languages for the response, and how it like yeah, this is my website is going to be look like. And I want to say again, like we have divided our backend in three parts. Like we can't keep the backend in one part, because if one backend fails, if there is any issue in uploading file, the MongoDB will be crash, and the translation server also crash. Translation server will be also crash. So the backend is divided into three parts is our main idea. Like, so if one is crashed, and other two will be working accurately. Yeah, that's it. Like this is our main workflow of a front end and back end. And we also discuss about the potential upgrades and drag implementation and LLM workings, and find directory backend Flask and some front end screenshots, use cases, versions, modifications. Yeah, that's it. Like there is nothing left. Yeah, thank you.